continue on in lesson 7.2. So I want you to put the title, lesson 7.2, notes 2. And it's an add-on because we did lesson 7.2, notes 2 yesterday, but we're going to practice a couple more of this same type of problem today. Because some different things can happen. And I don't want you to think that just because that might possibly happen, that means it can't be factored. Because I'm giving you all ones right now while we're learning this skill. I'm giving you ones that this will work for. Okay? So we're just going to practice. We're going to do, I want you to write down the polynomial, 6a cubed, subtract 9a squared, subtract 12, plus 8a. Okay, so now one of the first observations I make about that before I even see that there's subtraction in it, tell me something about that polynomial and standard form. It's not in standard form, is it? Okay. Now, they don't always necessarily have to be in standard form for us to be able to factor them, but typically if they are in standard form, they actually work better for us. But what we're going to do is we're just going to leave it like this, and we're just going to see what happens, so that if it ever happens to you, you're like, oh, that's okay. I can do this. This will work out still. So the first thing we're going to do is we're going to get those subtractions changed to add the opposite. We have a couple of subtractions there. So rewrite the polynomial, changing subtraction to add the opposite. And then we're going to do what? Put in parentheses. We're going to make our two groups. So now we're going to group them. We're going to let the first two terms be a group and the last two terms be a group. And remember, what we're doing right now is what we're trying to find is we're really actually trying to find the GCF of the whole 4-term polynomial. But to do that, we have to GCF each group first. Okay, so that's what we have to do to find that GCF of the 4-term polynomial. So what do you think is the largest number? We're working the first group. The largest number that can be divided out of 6 that can also be divided out of 9. Ian? 3. Okay. How about our variable parts? A cubed and a squared. What would be the largest number of a's we could divide out of those? A, right? A squared. Thank you for raising your hand. So we now have a 3 that we factored out, and an a squared we said can be factored out. So that's our GCF of that first group. So 3a squared. And now what's the result after we would divide that out? And if you need to show the division, do that. If you can do it up here, then you get to be, you do not have to show that. So 6 divided by 3. 2. A cubed divided by a squared. A. Okay, so there's, after we take 6a cubed and we divide out that 3a squared, our result is 2a plus negative 9 divided by 3.
Negative 3.
Negative 3. A squared divided by a squared.
They cancel out.
They cancel out, it's really 1, isn't it? So negative 3 times 1 would still be negative 3. So we can say there's our binomial factor for just that first group. When we GCF just that group, we have a monomial times a binomial, just dealing with that first group. Okay? Now let's look at our second group. What's the largest number that can be divided out of negative 12 that can also be divided out of 8? Brighton? 4. Okay, so we're going to say 4. And what is, how do you feel about trying to take some a's out? We can't? How come? There's no a's for the negative 12. If there's no a's for the negative 12, then we can't divide any a's out. So we're going to just be able to divide out our 4 is all. And we're going to have what as a result? Negative 12 divided by 4?
Negative 3.
Negative 3. 8a divided by 4?
2a.
2A. What's our goal? For the binomials to match. Do the binomials match?
Yeah, there's a different order.
So, does addition also allow order to change up, like we just talked about with multiplication? So in reality, we have here, this could be rewritten as 4 times these two could trade places. We would have 2a plus negative 3, right? Can we do that?
Yeah.
Yeah, trade.
Before we started, I switched my 8A and my 12.
Yeah, so if you switch them around, then you don't have to, then it comes out like this, doesn't it, Trey? Okay, so by putting it in standard form, it would have come out. But if you don't, if you just go to work with it not in standard form, I wanted you to see what could possibly happen, and does that mean we didn't get a binomial that matches? No, it just is in different order is all. So we really still have the same thing. They are matching binomials. So what's the GCF now of the whole 4-term polynomial? No, what's the GCF of the whole 4-term polynomial? Ariel? 2a plus negative 3 is actually the GCF of the 4-term polynomial, the one they have in common. So 2a plus negative 3 is really our GCF of the 4 terms, and that has to get multiplied times the result we would get when we divide that out of each of the terms. So after we divide 2a plus negative 3 out of this first term, what would we have?
3a squared plus 4.
We'd have, listen to what I ask. After we divide 2a plus negative 3 out of this first term, what would we have? We would have just the 3a squared. After we divide 2a plus negative 3 out of the second term, what would we have? 4. There's our other binomial factor, no plus signs between these two binomials. Our GCF is one factor, and what is the result after dividing that out is our other factor. Okay, now, does that need cleaning up? Yes, it does. So we clean this up and say this one is what? What's the first binomial? 2a minus 3. Does the other one need cleaning up? No, so we can leave that one like it is.
Do you want to check problems?
And we are going to continue to do check problems, but we're just not going to do them in the notes today so I can give you more homework time. Okay? So anybody have any part of that we need to go back and talk about? So you are going to continue on, you're going to do check problems in your homework on the evens again, but we're not going to do it in the notes just so we so you can get more time. Yes? No?
You know, in the blue, the rectangular box, how did you get 3A2?
How do we get 3a squared plus 4, that part?
Yes.
Okay, because that's why I was boxing this. What we're doing is we're dividing that 3a squared, 2a plus negative 3. We're dividing that term by our GCF of 2a plus negative 3. This cancels with that, and that's what our result is. Okay, so that's where that came from. And then the same thing over here with that one. We did the same thing there. Okay, that help? Anybody else? Okay, let's practice one more. And then you can go to work on homework. Okay, so put a second problem. Okay, we're going to do 3r minus r squared plus 2r minus 6. Now, what I want you to do is I know you're going to be tempted in this one to say, just like we talked about in the last one, it's not in standard form, is it? But what else is also true about this one?
It has two and one R's, or
Yeah, it-
one special, one time.
Yeah, it's got two terms that are just R's, R to the first power. So they're really light terms and they could be combined, couldn't they? But if we combine them, will we still have a four-term polynomial if we did that? No. And do you know how to factor a three-term polynomial yet? Have I taught you any way other than the GCF method of how to factor a three-term polynomial? No, so we don't want to change this into something we don't know how to do yet. So we're going to leave it as a four-term, and we're not even going to worry about that it's not in standard form either. We're just going to change it to add the opposite and go to work on it. Okay, so let's make it 3r plus a negative r squared plus, in fact, we can stick a 1 in there if you want, plus a negative 6. And then we're going to make our groups. Okay, let's start GCFing that first group. What do you think is the largest number that can be divided out of 3 and negative 1, Josh? 1. Okay, how about the r and the r squared, Josh?
Well, it'd be 1R.
It'd be 1r, wouldn't it? Yeah, so it's going to be 1r is going to be our GCF of that group. Were you offering an answer or were you asking a question? Did I call on you for the right reason? Okay, good. Okay, what's 3r divided by 1r? 3. 3r divided by 1r, 3. Plus negative 1r squared divided by 1r. What's negative 1 divided by 1? Negative 1. And what's r squared divided by r? R. Okay. So there's our first group factor. Okay, now we're going to bring down our addition sign, and we're now going to GCF the second group. What's the number GCF of it? 2 and negative 6. What's the largest number that they're both divisible by, Isaac?
2.
2. Okay. R's. Can we take any R's out of both of them?
No.
No. So 2 is going to be as good as it's going to get. 2r divided by 2.
R just
R. Plus negative 6 divided by 2. Negative 3. Okay. What's the next question we ask ourselves before we move on?
Are the two things in parentheses the same?
Are the binomials matching?
No.
Is 3 plus negative 1r the same as r plus negative 3?
No.
Even if I change these around, even if I did this and said, you know what, well, fine, I'll put the r's first. Maybe they'll match then.
No.
I'm going to put a 1 in front of that r just so it looks a little bit friendlier. Do they match? Huh. It's like the r's are opposites of each other and the 3's are opposites of each other. So what do you think we possibly could do to rectify that? Because we can make this work. Anybody have any idea what they think we can do to make it work, right?
Switch it so then the groups are 3r or minus 6 and the negative r squared or plus the 2r.
Hey, that might work. We could change up the terms and start with new groups. That sounds like a whole lot of work. I think there's even something, even a little bit less work we could do. We could try that though. Ariel?
Could you multiply one of the binomials by negative 1?
If you multiplied one of the binomials by negative 1, that would change them both to their opposites. So like maybe if we multiplied this by negative 1, 1r times negative 1, what would that be?
Negative 1.
Negative 1r. If we multiplied negative 3 by negative 1, that would be
Positive 3.
positive 3, and then it would match that, wouldn't it? Oh, well, if we multiply by negative 1, could we just change our GCF then to a negative 2? Think about that. Can we change our GCF to a negative 2 instead of using a positive 2? Remember how in the answer keys that I'm showing you, with GCF, you can have a choice of a positive GCF or a negative GCF. We're going to make our GCF negative is all. So let's do this. Instead, what we're going to do is we're going to make this a negative 2. By making that a negative 2, that means we would be multiplying both of these by, or dividing both, when we're up here, we'd be dividing by negative, so this is gonna change to its opposite, and this is gonna change to its opposite. So if we make that negative, make that its opposite, we have to make each of these its opposite also. So what we really are doing is we're changing it so that the GCF is not a positive 2, but a negative 2. So let's go back now and look and see if we did it right. If we divide out a negative 2, what's 2r divided by negative 2? Negative 1r. 2 divided by negative 2 is negative 1, and then we don't have any r's to divide by. What's negative 6 divided by negative 2? Positive 3. Okay, let's take this. I don't know if you changed your line. I'm just going to take this and I'm going to put a line through it and we get that out of there. And I'm going to show that instead what I use as a GCF is negative 2 rather than positive 2. Because now my binomials match, though that binomial is the GCF of the whole thing. So we're going to write negative 1r plus 3. That's our GCF. After it is divided out of both terms, what do we have? So after I divide negative 1 plus 3 out of this term right here, this is a term, what am I going to have? 1r, yeah. Plus, after I divide negative 1 plus 3 out of that one, what am I going to have? Negative 2. Do we have some cleaning up we can do? Yeah, let's clean this up. Negative 1r plus 3, how would they show that in an answer bank? Cameron?
Negative r plus 3 times r minus 2.
Yeah. So afterward, this would be, it's better to check it when it's using that form. We still like that name for checking. But when we're looking for the answer in an answer bank cleaned up, it would be negative r plus 3 times r minus 2. In fact, here's what else they might do. Here's what else they might possibly do. They might have that 3 and that negative r trade places and be 3 minus r times r minus 2. That's another possibility of what they would do in an answer bank. Okay, so you're going to come across some problems today that are going to kind of look like these two do. That's why we practice some like this too, so that you know that you can still do those also. Everything you come across is factorable. Everything you come across in your homework is factorable. Okay? You can't stop and say I couldn't do it. It's not factorable. It is. So let's get started on the homework. Again, you're showing, you can look at the answers, check your answers at the back of the book for the odds. The evens, you have to put a check down. We have 12 problems. We have 12 problems of homework, of which 6 of them would have check problems shown. Okay? Any questions? Is it?
You switched 3 to 1.
Yes, I did. I said this is another possibility of how it could be shown in an answer bank. Yep. Anybody else? Okay.
Yeah, I'll get you the thing to correct.
I'm just going to stop the recording and then I'll be able to bring it back to this after I save the recording, okay? I won't lose the notes. I just